A router uses information in its routing table to forward packets. A routing table displays entries listing all the networks that a router is aware of and the best path to reach them. It is very important to be able to read and understand the entries in a routing table. In this demonstration, we'll take a look at a router's IPv4 routing table in detail. But first, let's examine the network topology. It actually consists of 5 separate networks or subnets. There are 4 LANs, 2 connected to each router, and 1 WAN connection between the 2 routers. If we look at R1, it has 3 directly connected networks. Network 192.168.1.0 connected to interface G0/0/0, network 192.168.2.0 connected to interface G0/0/1, and network 209.165.200.224 connected to interface S0/1/0. R2's LANs are not directly connected to R1, therefore they are considered to be remote networks as far as R1 is concerned. In order to forward data to remote networks, a router needs to learn about them first through the use of static or dynamic routing. In this example, R1 has learned about them through the dynamic routing protocol OSPF, which has been configured on both routers. To view the IPv4 routing table, I'll click on router R1, and from the CLI tab, I'll press Enter to connect to the command line. From here, I'll type enable and press Enter to enter privilege exec mode, and from here, I'll issue the show IP route command to view the routing table. If I press the space bar, I will see the full output. At the top of the output are letter codes that indicate how each network, aka route, was learned. This is referred to as the route source. Underneath that, we can see the routing table entries. These represent all the networks that R1 knows about and the best way to reach them. Let's further examine some individual entries. First, let's look at the entry for network 192.168.1.0. The letter C in front of the entry is the route source and indicates that the source of this route is a directly connected network. And you can also see that in the entry here. Gigabit Ethernet 0/0/0 is the interface to which that network is connected. Now let's look at the entry for network 10.1.1.0. This entry has a route source of O, which indicates that it was learned via OSPF routing. After the network address, you can see 2 numbers in brackets that are used by the router to help determine the best path to the network. The first number is the administrative distance, which indicates the trustworthiness or preference rating of one route over another. Next is the metric, another value used by the router to help determine the best path. The metric may be calculated using hop count, bandwidth, or some other factor. This network is reachable via this next hop address, which represents an interface on router R2. This is a timestamp that tells us how long ago this router last received an update on this route. And serial 0/1/0 is the exit interface on R1 through which to send the packets. For the purposes of this demonstration, you can ignore any entries that do not list a route source at the beginning. These are basically headings. Also note that for each directly connected network, you have an entry below it with a route source of L. L refers to a local route, and basically this is the IP address of the interface to which that network is connected. This routing table shows that R1 is aware of all 5 networks present in the topology. It has 3 directly connected networks, It has two networks that are remote and were learned through OSPF routing. And lastly, if you look at the last entry in the table, you will see a statically configured default route. This manually configured route can be used to forward any packets that don't have a specific entry in the routing table. The purpose of a default static route is so that the router will not drop any packets. These are just some of the basics of an IPv4 routing table.